Hi everyone, my name is Benjamin, and in this video I'll cover how you can swap any Solana token and add that functionality to the token tracker which we built in the previous video. All that to get you started building on Solana. We are going to talk about swap settings like slippage, fee, and broadcast methods like Jito and priority, how to update the swap settings in our application and build a swap transaction using the Jupiter v6 swap API and our SVS RPC. We are going to discuss stake-weighted quality of service and how to improve landing times and accuracy. And on top of that, all the code will be available for download via our GitHub repository. Now this video is part of a series, so make sure to subscribe so you don't miss any of the upcoming videos where we will eventually create our own simple trading bot. So with that said, let's get started. Alright, so before we jump into the actual code base, I want to give you a quick high-level overview of the application that we already have and what functionality we will add. So, in the previous video, we created a Next.js app using ShatCN for the components. And if you want to know how we set up that project, I suggest you check out the previous video first, and then you can always come back to this video. But real quick, we created an app where we can add a token. It will validate the token to see if it's a valid token address. And if so, it will fetch the token prices and also some metadata like the name, the image, and the symbol. Once that is done, it will add it to a table, and in today's video we are going to look at the swap functionality, so we will be able to buy the token using the Jupiter v6 swap API and our SVS RPC. So we are going to focus on the green part here, and we will also provide the possibility for the users to add some swap settings, like for example the SOL amount we want to transfer into the token, the slippage, the priority fee, and of course the broadcasting method, like for example Jito or Jupiter priority fee. Now for this project we are going to use the Jupiter v6 swap API, and that API can tap into all kind of liquidity from different dexes within the Solana ecosystem. It's an aggregator that will allow us to seamlessly swap any token for any other token. Now besides being a standard for swapping tokens, it allows us a lot of flexibility when it comes to customizing our transactions. We can do things like add custom instructions, add cross-program invocations, and we can also choose what broadcasting method we want to use. We can choose which dexes or AMMs we want to route through, and we can even modify the number of accounts to use in a transaction. Of course, we will have to think about the upkeep of our own RPCs. We need to decide about transaction fees and things like slippage, and we will also have to think about parsing the swap results when a transaction fails or succeeds. Now, in my opinion, the Jupiter Swap API provides a lot of benefits, and that's why we will use it in this project, and we will dive more into all the specifics when we look at the code on how we will integrate it within our own application. Alright, so this is where we left off with our app the last time. What we could do is add a token address and then add the token. And the system would go and check if the token address is valid, of course, and if so, it will go and fetch the metadata like the name, the symbol, and the image, and also it will fetch the token price. We could sync the prices for one token or all the tokens. The next thing that we will do is add a button that will open a pop-up where the users can add settings like slippage, the amount of SOL they want to swap into a token, but also the broadcast method and the priority fee or the Jito fee. Now, to save these settings, we need some storage, and for this project we are going to use the local browser storage because we want to keep this app light and fast. So what we will do first is create these methods and functions that we can use in our entire app to save these settings into our local browser storage, but also retrieve them from our local browser storage to then use them when we are going to actually create a swap transaction. Alright, so we will need two functions, one to store these settings in the local browser storage and one to retrieve them. And to save that logic, I created a file called bysettings.ts, and I store that file in the utils folder, which I created under the source folder. So here we will have all our logic, and the first thing that we will do is create our types as we are using TypeScript. Now the first type is the priority type, and this will allow the users to choose their broadcasting method. As we are using the Jupiter v6 swap API, users can choose to broadcast their transaction or via their RPC endpoint that it will send to one of the leaders in the network, or they can use to broadcast via Jito, and of course they will have to provide a Jito tip for that as well. If you're using Prio, optionally you can use your own RPC endpoint, as we will do, the one we bought via the SVS cloud platform, or you can even opt for a staked endpoint, also known as a staked wait quality of service. And we will talk a bit more about that later on in this video. As I said, we can also choose to broadcast through Jito and include a Jito tip into our swap transaction. And of course, you need to have a Jito enabled RPC endpoint for that to work. And you need to provide the appropriate amount of Jito tip, of course, included to get your transactions processed. Now, after we created the types, we will also have a buy settings type, because our buy settings, they will hold the sol amount, the slippage, and of course the priority type and priority fee. And the priority fee can be the Jupiter priority fee or the Jito priority tip. Next, we will create a default settings object, which will hold default settings in case we cannot return our settings back to the user, or the users did not save any settings at all. We will have default settings that we can always fall back on, and these will have the type of buy settings, and that is the type that we created here on top. And the next thing that we will do is create our actual functions. And the first one is to save the settings in the local storage. And what we have to do first is make sure that we are running in the web browser. And the web browser has one of these objects called window. And if that is undefined, for example, if you are running Node on the backend server, then the window object will not be there. If it is defined, then we will know that we are running this function within a browser and that we will have access to the local storage. And then we can access the local storage, set an item called buy settings, and we can stringify our settings, which we will receive through the parameter of this function. So people will be able to save their settings by providing the settings to this function, and that function will save it within our local browser storage. The next function will do the opposite. Again, this will get the settings from the browser storage, and of course also here we have to check if we are within the browser window, and we do that by doing the same check. However, here, if we are not in the browser window or anything goes wrong, we will always return the default settings. If we are in the browser window, then we will of course again try to access our local storage and get the item called buy settings. And if it is not there, then again, we will also return the default settings. However, if it is there, then we will take these settings that were stored in this local storage, make sure that they are of the type buy settings, and return them parsed to our client. So with these two functions, we can now store our settings in the browser storage, and we can also retrieve them. And the next thing that we will do is make sure that the user have a pop-up where they can enter these settings and send these settings to these two functions that we just created. Alright, so as you can see, not much changed in our app, as we just created these functions to store and retrieve the settings. And the next thing that we will do is create a button over here that people can click, which will open a pop-up. There they can enter the settings and save them. So if we go back to our code on the page.tsx file, you will see that we have the sync tokens button here. And here we are going to add an additional component that will trigger a dialog. And that dialog will hold a form where people can enter all these settings. The logic of that form we will store in a file called buy settings dialog, which I created under the components folder. So we can have a look at that right now. So the buy settings dialog function will hold all the logic for this component. And the first thing that we will do is create a use state that we will use to track the actual state of our dialog. And the dialog can be open or can be closed, and we can set that state by using this state here. The next thing that we will do is create a state for our form data, as we want to have our form some default data, and we give that state the type of buy settings, and buy settings is declared in the file that we created earlier. So we are exporting this buy settings type so that we can use it within the buy settings dialog as well. And we give that state some default details, like for example the sol amount, we set it to 0.01, the slippage, and by default we set prio, and we also set a priority fee. The next thing that we will do is use the use effect hook, and this hook will run when the component mounts, but also run once one of these values provided here changes. And this means once our dialog is open, this will run, or at least it will be triggered. And we will go and fetch the buy settings via the get buy settings function, which we created here earlier. So that means then when these settings get returned, we will take these settings and store them in this set form state that we created earlier. So we know now for sure, once our component mounts, before our dialog opens, we will go and fetch these settings from our local browser storage and store them in our form state. The next thing that we do is create a function to submit our form, as we will create a form later on within our dialog. And here we just take the elements that have been returned from the form and we store them in a constant called settings, and that settings constant we assign the type of by settings, the same by settings that come from our by settings file which we exported there. And here we set the sol amount, the slippage, the priority type and the priority fee, which comes from the elements from the form. And then we will take that settings constant and send it to the save by settings, which in turn receives a parameter from the type by settings. And that is why we here send a object called settings from the type by settings into that function. And that in turn will store these settings into the local browser storage. And then we will also make sure that our dialog is closed by setting the setIsOpen state to false. Next, we have our elements from our dialog here. And the dialog, we control that by using the state. Again, if it open, we set it is open. And on open change, we use the setIsOpen. And that is the state that we use for that here on top. And that is how we control and know the current state from our dialog. Next, we will create a dialog trigger. And in this case, it is just a button. Once this button is pressed, we'll open the dialog content. Now, the dialog trigger has the asChild attribute, which means that it will render as its child, in this case the button, but it will still hold all its own attributes. The dialog content holds a dialog title, of course, called by settings, and a form, because this form, once submitted, it will send all its data to the submit form function, which we created here earlier. And as you can see, this form will hold all the inputs that we will need to store these values, as for example, the sol amount. And the sol amount is just an input field of the type number. And of course, the default value will refer to the form state, which is set once the component mounts. And on change, we will also set the form state and we spread the current values and then we add the sol amount from the target from this input. Now we also have a slippage input. It's the same, it's the number type that we assign it. And here we can provide the slippage. And we will also have a select field for our priority type, which can be or Jito or Jupiter priority. And last, we have an input field for the priority fee or the Jito tip. But that is the form. And once it is submitted, or once we click the button Save Changes, the form will be submitted and it will send it to the submit form function. And that function in turn will send these to our save by settings function, and that will store it within our browser settings. Now, the last thing that we need to do to show this button actually on our page is include this element on our page.tsx file. And what we can do is wrap these two buttons into a div with a class name flex space x2 to make sure that these buttons are shown next to each other. And once we wrapped this first button into that div, the next thing that we can do is take this element by settings dialog and also import it here into our page. And we need to make sure that we import it from the by settings file, and then we can just close it like this. And if we now open our actual app, then you will see that we now have a by settings button. And if we click that, this will open a dialog where we can enter our swap settings. And as you can see, we have swap settings here. And these settings, once we click the save changes button, will store these settings in our browser storage. So we can check that by going to more tools, the developer settings, and then under application, under storage, you can click on the localhost 3000, and here you will find a key called by settings. And as you can see, it says sol amount, slippage, priority type, and priority fee. And if we would change this to 0.1 and we set the slippage to 25 and we click the save changes button, then you will see that these changes are being reflected here. So now we know that our button for the swap settings work. And the next thing that we can do is create the actual swap functionality where we can also send these swap settings to and then swap the actual token. And after that, we can integrate the buttons into our table to trigger a swap and also get back the information if the swap was successful or not. Alright, so our swap function will consist out of the following steps. We will take our swap settings like the slippage, the sol amount, also the priority fee, and we send that to the quote API from Jupiter. That quote API will return to us a quote, and to that quote response we can attach a wallet. What we have to attach is actually a wallet public key, but we will have to have access to a wallet that we create or a key pair that we create. And a key pair is just a public key and a private key. Once we attach that public key, we can send that quote response back to the swap API. And that swap API will return to us a serialized transaction. Then we can take that transaction, deserialize it, sign it with our wallet key pair, and send it via our RPC to the network. And then we can wait for a confirmation and see if everything went well or not. And then we can send that result back to our client and add that into our table. Now, before we jump into the actual swap logic, I want to briefly highlight how you can create a key pair and restore a key pair from a private key. And if you go back to the Solana cookbook documentation and you scroll down a bit, then you will see under wallet management how you can create a key pair. And they have a TS kit method and they have a TS legacy method. Now, I created a few examples here that we can look at on how to create a key pair and also restore it. So the first example that we will look at is how to create a key pair using the legacy method. And for that, we will just create a new key pair using the key pair method that comes with the Solana Web3 package. And that key pair then we can turn into a public key using the new public key function. And we can also turn that into a private key base64 format. And then we can output these in our console, or we can even save that into the wallet.json file into our file system. If we run this now, then you will see that it will output a key pair for us. It will output our private key and our public key. And here on the side, you can see that we now have a wallet.json file that also holds our private key. Now we can do the same using the generate key pair signer from the Solana kit. And to do that, you just need to create a new constant and await the generate key pair signer function. And then we can also output what is returned to us within the console. Now to restore these key pairs, also for that, there is an example in the Solana cookbook, so we can have a look at that. You can or restore from bytes, and these bytes will be saved into that wallet.json file, or we can restore from a string, and this string we also output it earlier. So also for this, I have an example that we can look at real quick. So here we can restore a wallet using the legacy method. So what we will do is import these wallet.json file contents into the wallet data constant. We will then parse them into JSON and then turn them into key pair bytes using this secret key array. And then from these key pair bytes, we can create a new key pair using the key pair from secret key. And then again, we can create a new public key and a private key and output them within our console. So if we run this now, then you will see that we recreated both the private key and the public key from this wallet.json. And of course, we can do the same using the tskit method. And also here we can read in our file contents, parse them into a JSON file, create the key pair bytes, and then use the create key pair signer from bytes. And that will also provide us with a public key and a private key. Now in our own swap logic, we will recreate our key pair from our private key stored in our environment file. That we will cover when we are looking at the actual swap logic. Now there's also a third way that you can use to create a new key pair, and that is the Solana CLI. And if you go back to the Solana documentation under installation, you will find how to install the Solana CLI. Now, if you're running Windows just like me, you will need the Windows subsystem for Linux. And on top of that, you can install the Solana CLI. And you can find all that information here within their documentation. So here within the Windows subsystem for Linux, I installed the Solana CLI. So once started, what we can do, for example, is type the Solana config get, and that will show us our current config. And here we can see that we have our config file stored at this location. Our current RPC is set to devnet, and we have the WebSocket URL and a key pair all within this config. Also, the commitment is set to confirmed. So what we can do now is create a key pair, for example, using Solana keygen new. And I'm using the force flag as I already have a key pair set, as you can see here within the config. So if I run this, you will see that it will prompt me for a passphrase. And here you can just enter anything or nothing. It's up to you. So for now, I just enter a random string. And as you can see, it created a public key for me. and it also stored a new key pair within this file location. So we can take this, and if we cat this real quick, then you will see that it outputs here the same exact private key that we saw within the wallet.json. Of course, it is for another key pair, but we created an additional key pair using the Solana CLI. Alright, so now that we know how to create a key pair and recreate a key pair, I think it's time to look at our own swap logic. And the swap logic I will host here under the token service.ts file, which we created earlier in our project to check the token prices and also to verify if a token address that was provided is valid. So now we will add our swap logic here as well, and the first thing that we will do is create our types. And the first type that we will create is the swap information that will be used to return information back to our client. And here we have a success value, and if the swap was successful, it will be true, and otherwise it will be false. And if it is false, we will also return a message to let the user know what happened. However, if it was a successful swap, we will return a transaction, the token address, of course, the amount of tokens that we swapped into, and the time. And besides that, we have a Jupiter swap quote response and a Jupiter swap response. And these are based on the responses that we will get back from the Jupiter quote API and the Jupiter swap API. So if we look at their documentation real quick, then we can see how we can request a quote and what type of response we will get back. And based on this response, we created our type. The same for the swap transaction. Here you can see how you can request a swap, and here you can see what response you will get back. And based on this response, we also created our types. And now we can use these types to attach them to our responses that we will get back from the Jupiter v6 swap API, and we will exactly know what values we can use and not. Alright, so now with our types declared, we can continue with looking at the swap logic. And we created a swap token function here that requires a token, of course, and the buy settings. And the buy settings we will provide because we have stored them in our local browser storage. And first, we will check if we have received a token and the buy settings, and we will start a performance counter to see how long it roughly takes to land our transaction. Now next, we will set some required parameters as the token mint. We will extract the values from our buy settings like the priority fee, the priority type, the slippage, and the sol amount. And next, we will get the private key and the RPC URL from our environment file, which lives in the root of our project. In that environment file, I created a copy, and that copy you can always rename to .env. And within this .env, you can set your private key using one of the methods that we looked at earlier, and you can also set your RPC URL. And if you are using one of Solana Vibe Station, you will have to set your API key here as well. Once you have done that, you can install the package .env and you can initialize .env.config, and then you will be able to access these environment variables within your script. Now, once you have access to all these required parameters, we can set up our wallet, because remember, we will need a wallet to sign our transactions. And we can create a new key pair using our private key that was stored in our environment file. And we do that by decoding it into a base 58. And also this package you will have to install using npm. And once you have imported that package here, you can turn this into a secret key. And once you have turned this into the right format, you can use the key pair from secret key method and enter the secret key here. And that will create a key pair for you, or a wallet key pair. The next thing that you will have to do is set up an RPC connection, because remember, once we have our transaction signed, we will have to send it to our RPC. That in turn will forward it to a valid leader. And to do that, you can use the new connection, and also this comes with the Solana Web3 package, and you will have to provide your RPC URL. And you set your commitment level and then store it into the RPC connection value. Now, if something goes wrong with creating our wallet or our RPC connection, we will return false in the format that we specified here on top within our swap information interface. And as you can see here, if we could not create a wallet, we will return false saying failed to create a valid key pair. And if we could not create the RPC connection, we will return false saying failed to create a valid RPC connection. So our end users always know what is going on. Alright, so now that we have everything in place, like our wallet and our RPC connection and also the required parameters, we can continue with requesting an actual quote. And we can do that by sending a GET request to the Jupiter quote API, and we will have to provide some information, like for example the input mint, which is the Solana mint, our output mint, which is the actual token that we want to swap, the amount, which is the sol amount times the lamperts per sol, because we have to provide it in lamperts, and lamperts per sol comes with the Solana Web3 GS package. Also slippage BPS, and also the only direction routes set to false and as legacy transaction to false. Now slippage we need to do times 100 because we have to provide it in basis points, I believe. And once we have set all these parameters, we can send off this request to the Jupiter quote API. This in turn will return us a quote response, and that quote response we will have to forward to the swap API. But besides the quote response, we also have to provide the public key from the wallet that we created earlier. We need to specify that we want to wrap and unwrap SOL, because we can also in theory have wrapped SOL in our wallet, and then we can set this to false. Dynamic compute unit limit we set to true, and skip user account RPC calls we also set that to true. And the prioritization fee lamports, that object is created based on if our user chooses Jito or priority as their broadcast method. And if they choose Jito, then we will have to provide the Jito tip in lamports. Otherwise, we have to specify max lamports global and the priority level. Once we have set up all that, we can send the request to the swap endpoint, and that will return to us a swap response, including a serialized transaction, and it will also let us know if the transaction simulation was successful or not. So the next thing that we will do is of course check if we received a swap response, and also check if that swap response included a simulation error. Because if that included a simulation error, that means that our transaction was simulated, but it was unsuccessful. And that means in turn that we will have to return false to our end users. Now, if there was no simulation error, then we can create a transaction by taking that serialized swap transaction that was returned to us, deserialize it, turn it into a version transaction, and sign it using the wallet that we created earlier. And then we can send that transaction using our RPC connection that we initialized earlier, and see if we get a signature returned. The next thing that we need to do is see if it can be confirmed. And to do that, we need to create a confirmation strategy, and that confirmation strategy object needs to have our signature, it needs to have the block hash and the last invalid block height. And then we can take this confirmation strategy, use our RPC connection to confirm our transaction, and if we get back 8 confirmation, then we can see if it contains an error or not. And if it contains an error, then we can return false, because then our swap was unsuccessful. Otherwise, it was successful. And then we can stop our performance counter, we can calculate how long it took, and return true in this case. We will not include a message because the swap was successful, so we will include a signature, a token mint, the quote response data out amount. This will include the amount of tokens that we received for the Solana that we paid, and the elapsed time based on the performance counter. And then we can return this all in the format that we specified here on top, the swap information interface format. And then our client can take this information and display it properly within our app. Now, besides displaying these tokens that were successfully swapped, we need to make sure that we can track them, because if we restart our application, we need to make sure that they are present in the overview. And to do that, we can also track these tokens within our local browser storage. So what I did, I created some additional logic in the buy_settings.ts file under utils, where we created our functions earlier to save our buy settings in the local browser storage. And we are going to do the exact same for our successfully swapped tokens. So the first thing that I did is create a token purchase interface, which will represent these purchased tokens. And we will have a transaction, the SOL amount, the amount of tokens, the time it took, the token, the name, and the image. And the next thing that we can do is create a save token purchase function, and that will receive a purchase in the format of the token purchase interface. And what we can do first is check if this runs in the browser just as what we did earlier. And if so, then we can get the current token purchases. And that function is declared here underneath. And that function in turn will just get the local storage get item token purchases. And if there are none, it will return an empty array. Otherwise, it will return the purchases that are already stored in the browser storage. Now, if these are returned, what we will do is use the unshift and then add the purchase that we are trying to add to that array. And then we will store it once again in our local storage using the set item, given the token purchases name, and stringify our purchases array to store it neatly in the local storage of our browser. Next, we will also have a remove token purchases function that we can use to remove purchases from our overview in case they are sold outside our application. And we only need to provide the transaction ID, and based on that transaction ID, we can look into that purchase array that we can get back from the current purchases using the get token purchases function. And then we can use that transaction ID to look within that object and remove it using the splice method. And once it is removed, we can store these purchases once again in our local browser storage under the token purchases key and make sure that it is JSON stringified. So once we have these three methods or functions, we can use them to save swapped tokens that were successfully. We can also get the successful swapped tokens to show them in our app, and we can remove them if they are sold outside our own application. Now the last thing that we have to do is tie it all together and make sure that we have the buy buttons in our app and also an overview of all these successful swapped tokens. So what I did is create a buy button in each row of the tokens that have been returned to us. So before we had the sync button, and now we added a button saying buy. And that button can trigger a function called buy token once clicked. And if we look at the buy token function, what it will do is first set the set failed purchase state to null. And this state we will use to show a message in case the swap was unsuccessful. And that state is declared here on top. The next thing that we will do is fetch our buy settings, and that we can do by using the get buy settings function that we created earlier. That will fetch the buy settings from our local browser storage. Next, we will use our swap token function that we created earlier, and here we will provide our token address and the buy settings, and that will return to us if it was swapped successfully or not. Remember, it will be a success value that holds a boolean, and that boolean will be true or false. And if it is false, then there will also be a message that explains to us why the swap was unsuccessful. And then, if that is the case, then we will store that message in the set failed purchases state, and then we can show it into an alert into our application. If it was successful, then we will extract the amount, the time, the token, and the transaction from the swap object that was returned to us. And the next thing that we will do before storing this token is fetching the actual prices, the name, and also the image, just as we did before, because we want to have the current price. And to do that, we can use the get token prices function, which we created earlier. Next, we will create a nice object where we can store the transaction, the sol amount, the amount of tokens that was returned, the time, the token itself, the name, and the image of the token. And then we will take this object and send it to the save token purchases function that we just created. And that in turn will store that purchase into our local browser storage. And finally, we will update our set purchase counter with 1 so that we can re-render the table overview with all our purchased tokens. We will wrap this into a try catch statement, so if something goes wrong overall, we can still set a set failed purchase message and display it to our user. The next thing that I added is a use effect, and this use effect will be triggered once the component is mounted and also once the purchase counter is increased or decreased. And what it will do is get the actual purchases from the local browser storage using the get token purchases function and store it into a state called set purchases. And set purchases is also declared here on top, and purchases will be used to actually render our table with all the purchased tokens. For that table, we created an additional card, and in that card we have the overview of all the tokens. So what we will check is if we have any purchased tokens, and if that is not the case, then we will just show a message that we are waiting for tokens and that no tokens have been bought yet. However, if we have tokens, that we will loop through them and create a nice table showing the actual name, the image, the token amount, and also the sol amount that we bought the tokens for and how long it took in seconds. And we will also create a remove button that we can use to remove the token purchase from our local storage if we sold the token outside our application. And for that, we have a function called remove token. And if we look at that function, what it will do is set the set failed purchase state to null. And then it will use the transaction that we provided to remove the token purchase from the local storage. And of course, it will also decrease or increase our set purchase counter to regenerate our table overview with all our purchased tokens. So once we have done that, we can start our application once again. And once it's started, you should see now a table for our tokens that have been swapped. Of course, we didn't buy any tokens yet, and it will say waiting for tokens. Now what we can do is import some tokens and see if they show up. And after that, once they have shown up, we can actually try to buy them, because now we can see a buy button here as well. We also have the buy settings, which we can specify here. And for now, we can set the sol amount to 0.001 with slippage of 25. And we can choose prio as the broadcasting type. So we can save the changes and then we can try to buy these tokens. And if you buy these tokens, you will see them appear within this table here. And it will also show how long it took on average to buy this token. We can also buy this token, and if that is successful, it should also show up in the table, also with the actual duration of the swap. And we can also see how many tokens we actually received. And if we click on it, it should also open the actual transaction details within SolScan. So if we go back now, you will see that our app reruns. And of course, the tokens that we imported, they are gone. But the actual tokens that we swapped, they are there. And that is why we store them within our local browser storage. Now, if we would sell any of the tokens, we can still choose to remove them via the remove button. So if I open our wallet here and we log in real quick, you will see that we now have these two tokens here. So if we choose to swap one out again for Solana, what we can do then is just click on the remove button and it will be removed from our storage. So if we refresh our browser now or our app, you will see that it is no longer there. Alright, so now that our app is working as expected, we can see that it returns the swapped token in about 2 seconds. But keep in mind, this also includes the internal processing of our app and the requests made to Jupiter to get a quote and build the transaction. To get a more accurate idea on how fast the transaction actually lands on chain, we are going to tweak our performance counter just to measure that. And after that, we'll purchase a staked RPC, and I'll explain how that might make a difference. And then we will do the exact same swaps with that staked RPC and see if we notice any differences. Alright, to tweak our performance counter just a little bit, what we can do is go back to our swap token function, and here you can see that we start the performance counter straight at the top of our script. So before we run everything. Now what we can do is add an additional start of this performance counter just before we are going to send the raw transaction, and then we can call that start time transaction. And then later, when we are going to return our result, we can include the time it took just to land the transaction within the elapsed time constant. So what we will do is slightly modify what we will return, and we are not going to only return the time it took for the whole function, but we are also going to return the time it took to land the transaction. And that we can do by just returning a string that includes the transaction time, where we do the end time minus the start time of the transaction. And we also include the overall time, where we do the end time minus the start time. And that should return to us the time it took to land and confirm the transaction, and also the overall time of running the swap function. And then the last thing that we need to change is back in our page.tsx file. Here we are now returning more than just the time, so we can remove the seconds, and then we can show the actual string that we are returning. So if we start our app once again and import both Divine and Imagine token, what we can now do is buy these tokens once again. So first we will buy the Bonk token, and then we should see the time returned for the actual transaction and the overall swap function. And we can also buy the Vine token, and that also should return us the time of the transaction and the total swap function. Alright, so the next thing that we are going to do is buy a staked RPC service. And we are also going to check how that can actually benefit us. So if you go to the docs.solanavibestation.com, there you'll see that we have information on all the services that we provide. And if you click on Node Services and then Staked RPC Services, there you will find a nice overview about the background of Staked RPC Services. So it says here, Staked RPC, or also known as Stake-Weighted Quality of Service, is a feature of the Solana blockchain that was released during March 2024. And to put it simply, it allows users to send transactions on Solana and have them confirmed faster than compared to using a regular RPC. And it also mentions that it is beneficial in times of high traffic or when the Solana network probably is congested. And here it says, when an RPC attempts to forward a transaction to a leader, at any given moment, it must compete with other RPC nodes in order to establish that connection to a leader. And a validator leader can only handle a finite amount of connections at any given time. And it says by default, 80% of these connections are reserved for stake nodes, and the other 20%, the leftovers, are there for the unstaked nodes. So a RPC node configured with this will forward all the transactions sent to it through the staked validator it has the connection set up through. And the validator then forwards the transactions to the current Solana leader validator in order to get it processed and added to the blockchain. You can find more information about this feature within our documentation. Now, this feature doesn't necessarily mean that you will get priority and put in front of the line, but it will make sure that your transaction is sent to a leader validator and eventually added to the blockchain. So the next thing that we will do is purchase a staked RPC service. And to do that, you can go to cloud.solanavibestation.com, and once logged in, you can click on the Place New Order. Next, you will have to select Node Services, and then you can click on Staked RPC Services. And here you can select your product, and of course we are going to order the basic staked RPC. But there are different tiers that you can choose from. And once you've chosen your tier, you can just select the billing cycle. And if you have any promotional codes, you can add them here and click order. Once ordered, under services, you will see Solana Node Services. And there you will find the information about your staked RPC service. And once you click that, you can click on the staked RPC. And here you will find all the information, including your API key and the connection details that you can use to connect to your staked RPC node. So what we will do now is copy the secure RPC URL and add it to our app. And remember, the RPC URL is configured within the environment file. So what you will have to do is update the RPC URL variable, making sure that it points to the staked RPC connection. Now, if we restart our app once again and import the same two tokens, what we can do now is buy them again and see if it makes any difference within the duration. And first, we will buy the Vine token, and after that, we will buy the Bonk token. And you can see immediately that both of these transactions are now landing under 1 second compared to 1.3 and 1.07 seconds before. So we are noticing a slight improvement. And of course, the staked RPC features are most beneficial when the Solana network is highly congested or highly in use. Nevertheless, it's great to see that we can land these transactions even faster using a staked RPC service. Now, besides that, we also have to set competitive priority fees. And priority fees are always important. It doesn't matter if you're using a staked or unstaked RPC. If you want to land these transactions quickly, priority fees are important. Another factor that plays into confirmation times are the commitment levels. Now, after that we send our transaction, we could choose between 3 commitment levels, which is finalized, processed, and confirmed. These are used to measure the network confirmation of the block that includes our transaction. For now, we are using the processed commitment level. However, you can choose to go with confirmed or finalized, and this will give you more certainty that the transaction landed. Of course, it might take a bit more time. Besides that, we also need to make sure that we set the amount of compute units correctly. And in our app, we are using the dynamic compute unit limit from Jupiter, which is great because it will return us a simulation check result, which it runs internally to get these compute units. However, you could choose to set these compute units yourself and skip the entire simulation check. Of course, you might end up with more failed transactions. Now in our app, we're also choosing to wrap and unwrap our SOL. However, you can trade any SPL token on Solana using wrapped SOL. This will make it even faster and convenient, as you may avoid one additional instruction. Of course, you need to make sure that you have wrapped SOL within your wallet. Now we also have to make sure that we set the ideal slippage for our app, and slippage refers to the expected trade price and the difference that the actual trade was executed. However, depending on the use case of your app, you might go with high or low slippage. And finally, we can choose to optimize our own app. For now, whenever we swap a token, we always recreate our key pair from the private key, and we also recreate our RPC connection. We could choose to create these whenever our app starts and then store them into singleton instances which are global within our app, and then we can tap into these whenever we want to swap a token. We can also make sure that our app runs on a fast server or VPS and that it is physically close to the nodes that we are interacting with. Now in the end, there is a lot of factors that contribute to fast transactions, but I'm happy that we could highlight some of these in this video. Now in the next video, we are going to discuss WebSockets and gRPC streaming, and we are going to see how they compare to each other if it comes to speed. So if you think that is interesting, like the video, and I'll hope to see you in the next one.